and good morning, everyone. Thanks for being with us here today for our 11 a.m. press conference on marine carbon removal research, funding, applications, and ethics. With us today, we have Lisa Graumlich, current president of AGU, and she's also a climatologist at the University of Washington. Steve Thur, assistant administrator for Oceanic and Atmospheric Research at NOAA. Gabriella Kitch, program lead for carbon dioxide removal at NOAA. Rory Jacobson, senior advisor for deployment at the U.S. Department of Energy. And Matt Eisman, chief scientist and co-founder of EbCarbon, a startup company developing a marine carbon dioxide removal pilot project in Sequim, Washington. I'm going to turn it over to Lisa to give us an introduction to the panel.
Thank you, Liza. And before I introduce the panel, I'm looking out at this audience, and I just have to say, I am so grateful that you, given all the demands on your time and the deadlines I know all of you are working on, are choosing to spend this next hour with us. I would argue that some of these questions of climate interventions, and particularly marine carbon dioxide removal, are some of the biggest questions we're going to see facing society. And I think having a good relationship with those of you who ensure that we partner to get the word out and to increase public literacy on these issues is really critical. So I'm looking at all of you. So grateful you're here. So I get to introduce Steve, and it's a really great pleasure. Dr. Stephen Thur was appointed as the Assistant Administrator for Oceanic and Atmospheric Research in October 2022. In this role, Thur oversees research activities in 10 laboratories and 6 research programs that focus on understanding the complex systems that support our planet. No pressure, Steve. Dr. Steve Thur's career with NOAA has focused on applying science to the management, restoration, and conservation of marine resources, with a particular emphasis on how the biophysical and the social sciences are used to sustain coastal ecosystems and the vibrant communities that depend upon them for livelihoods, for recreation, and as a place for connecting with nature. Steve. Thank you for joining us.
Thank you, Lisa, for that introduction. Liza, thank you for organizing this panel. As part of my employment contract as the Assistant Administrator for Research, I have to share data with you. And so I'm going to get some of that out of the way. My role in this panel is to set the stage, to give you the context, the why around marine carbon dioxide removal. So according to NOAA's National Centers for Environmental Information, in the 174-year climate record, this past October marked the 5th consecutive month in which our planet set a record for mean monthly surface temperature, meaning that every month from June to October was warmer than any such month in the last 174 years. October also marked the 7th straight month in which our planet set a monthly sea surface temperature record. And our planet is not just setting records, it is literally shattering them. For October, the average global surface temperature was 2.4 degrees Fahrenheit or 1.34 degrees Celsius above the 20th century mean, and that was 0.43 degrees Fahrenheit and 0.24 degrees Celsius above the previous record. We were a full quarter degree globally above the previous record set in 2015. Year to date through October, the surface temperature was the warmest 10-month start to any year in history. And according to NOAA's Global Climate Report, there is a 99.5% chance that 2023 will be the warmest year on record. The next report covering the month of November comes out tomorrow, December 14th, and we expect it will be very, very similar. Not only has it been hot, it's been exceptionally dry. The year-to-date precipitation totals in the contiguous United States through November rank as the 3rd driest in that climate record. And these changes are having massive economic impact. As one example, through the month of November, we have had in the United States at least $25 billion weather and climate disasters. To put that in context, the 43 years for which we have this data, from 1980 through 2022, we have averaged 8.1 such events per year. In the last 5 years, the average has been 18 a year. The previous annual record was 22. We've had 25 already this year. Those are inflation adjusted numbers, so we compare apples to apples. That's the context in which we find ourselves, and that is why we are talking today about marine carbon dioxide removal. Our changing climate is the largest environmental, economic, and social challenge of the next half century. It will impact how we grow our food, where we live, the employment opportunities we and our progeny have, and our public infrastructure, roads, hospitals, schools, firehouses. NOAA research has identified 4 societal challenges that we are going to seek to address through our research. The first among those is addressing our changing climate. I'll be reintroducing these concepts this afternoon in the One NOAA Leadership Town Hall. But as you can see from this slide, understanding our Earth system and mitigating the negative impacts from climate change is our highest priority. It is central to all of the other 3 societal challenges that we will orient our research around in the coming decades. It's a wonderful opportunity to be here with all of you, through your writing and communications, to reach the public about the importance of addressing our climate challenge and the role carbon dioxide removal plays in that. It's been a landmark year for federal investment and NOAA involvement in carbon dioxide removal. We know that to reduce emissions and meet the goals set out in the Paris Agreement, we have to shift from delivering energy needs through fossil fuel combustion to sources that do not emit carbon. Earlier today at COP28, the concluding statement referenced the need to transition away from fossil fuels, and this is the first time such a concluding statement has addressed fossil fuels. That's absolutely critical. It will address new emissions. It is likely insufficient. We will have to go one step further, and that is pulling legacy carbon from the atmosphere via carbon dioxide removal and other methodologies. NOAA, our agency, is viewed as a leader in carbon dioxide removal, as reflected in being the lead agency in 17 of 22 actions on carbon dioxide removal outlined in the White House's Ocean Climate Action Plan. However, these capabilities are currently under-resourced and were largely supported through one-time Inflation Reduction Act funding. It's also completely clear that NOAA cannot do this work alone. The value of collaboration across the federal government and with the private, nonprofit, and academic sectors is going to be absolutely critical. We have developed very strong relationships with others, and we are looking to develop new ones to address marine carbon dioxide removal. As illustrated by those on this panel today, we have relationships with professional societies, other federal entities, the private sector, addressing marine carbon dioxide removal, and I look forward to hearing their comments. Thank you.
Thank you, Stephen. One of the things I want to compliment you and your partners and your colleagues at NOAA is I so appreciate this framing that you have brought forward since the start of your work as the assistant administrator, and think that that's so powerful, because there's no denying that climate intervention has moved past the theoretical stage and the science is maturing fast. So AGU believes that research is absolutely vital to understanding the efficiency and the risks. And this must be done in the context of an ethical framework that guides responsible decisions at all levels, from that of an individual scientist to large intergovernmental agreements. AGU's position statement was updated in 2023 to read, "The urgent priority of a healthy climate requires enhanced climate intervention research and community engagement." It notes that climate intervention cannot substitute for deep cuts in emissions, as well as adaptation. That said, research aimed at understanding the benefits and impact of climate intervention measures is necessary and must consider global transparency, ethical and inclusion practices, and are subject to robust governance and oversight structure. I will speak further about exactly how AGU is collaborating on the framework and where we're headed. But right now, let's hear from our next panelist, Dr. Gabrielle Kitsch. She's NOAA's program lead for carbon dioxide removal. Gabriella.
Thank you so much, Lisa, and thank you for rooting us all in the ethical framework, which is critical to this field and moving forward. So I want to take a step back for a moment. We're here at the AGU meeting, thinking about the Earth system as one whole. And I want to bring us back to the importance of the ocean. So the ocean is really our driving force behind climate. It also provides naturally climate mitigation potential, right? So the ocean absorbs nearly a third of our emissions each year. And it has the potential to draw down 17 times more carbon than what is possible on land from biomass and soils. So the ocean has a large carbon potential for us when thinking about climate mitigation. When we're thinking about marine carbon dioxide removal, specifically, we have a host of different techniques, and I promise we're not going to get very technical here today, but I did want to outline these different pathways for everybody. So really, our different pathways range from restoration all the way to engineered solutions. So oftentimes people think about blue carbon, and blue carbon is a conversation and a topic that people have been considering for a very long time. And really, in the marine CDR space, blue carbon is a slow trickle of carbon into the land. So we think about it more potentially as storage, right? It's a flux that could go back into the atmosphere pretty quickly, but it is important nonetheless. Today, we're going to focus on research that looks at more emerging marine CDR techniques. So those really take the flavor of augmenting biological pathways and also chemical pathways. Some of the specific names are written up on the slide here today. And then we also have engineered solutions. So really thinking about stripping carbon dioxide off of water, off of seawater, and putting that carbon elsewhere in the Earth system. NOAA has been engaging on marine carbon dioxide removal research and carbon dioxide removal at large. So Steve, thank you for pointing out NOAA's momentum in this space. In June, NOAA produced a carbon dioxide removal research strategy. You can access the strategy through the QR code here on the screen. And this strategy is broken into 4 parts. We talk about the federal motivation to engage on carbon dioxide removal research. We talk about the state of the science. I encourage you to check out our figures in that section. I think they're especially useful to the conversation in this space. We also talk about NOAA's existing assets that could be leveraged to engage in the carbon dioxide removal space. And then lastly, we talk about a vision for CDR research at NOAA. So I point out here today the topics that fall into that third bucket, NOAA's assets that could be leveraged. And we really think about these assets in 4 different categories. So as many of you all know, NOAA is a leader in observing networks, especially when it comes to oceanic carbon. We support over 50% of the global carbon monitoring that can help us get at baseline carbon measurements to look at the effect that we're having from carbon dioxide removal. We also are leaders in global modeling that will be useful for projections for carbon dioxide removal. Of course, the ecological impacts, which has huge ethical implications. NOAA is a leader in that research as well. And lastly, decision support, which is really key to NOAA's mission in terms of both data management, but also marine spatial planning and other decision support tools. I also wanted to call attention to the first of its kind marine carbon dioxide removal research portfolio, which I'm really proud to announce, especially alongside our Department of Energy colleague here. I think this is a really strong program that highlights the collaborative efforts among the federal government and also with private partners. And so we utilize the National Oceanographic Partnerships Program, which is a vehicle that's been around since 1997, has supported over 200 scientific projects on ocean science. And the NOP, or National Oceanographic Partnerships Program, was really created to address research that cuts across agency mission lines. So we utilize this vehicle NOAA led a call both in 2022 and 2023 to support marine CDR research, and you'll hear from our grantee from Ebb Carbon, who supported in both of those calls. In 2023, the amount was much larger. We were able to leverage $24.3 million to support 17 unique projects. And what's really, really great about the National Oceanographic Partnerships Program is that we had to bring together partners from academia, from government, and from industry in order to be eligible for this call. So while we supported 17 projects, we actually are supporting nearly 80 unique PIs through this one opportunity. So really happy for folks to talk about that program today. And then I also will plug one of our grantees is presenting here at AGU tomorrow. And I'll also be giving a longer format talk at the NOAA booth at 2:15. Some of our PIs will probably stop by at that time as well. So if any of you are interested in engaging more, please feel free to check those opportunities out. With that, I will pass it to Rory Jacobson from Department of Energy.
Thank you so much, Dr. Kitch, and thank you to the AGU and to NOAA for having me here to represent, is the mic on? Can you hear me? Okay. To represent the marine carbon dioxide removal work that Department of Energy is doing. And it's been phenomenal to collaborate with our colleagues at NOAA, specifically given that they've already built out a strategy on this topic. And I want to flag that while my title is Senior Advisor for Deployment, the Department of Energy doesn't actually think we're ready to deploy many of these technologies yet. And we need to build a firm understanding of the ethical implications, the ecosystem impacts of all of these technologies before we actually move towards commercialization or deployment. And so I talk about a lot of sort of our applied research and development portfolio and some of the work that we've done with NOAA, but also internally at DOE on these topics. So I do want to point out sort of two key drivers for why Department of Energy thinks about marine carbon dioxide removal. The first of which is that Congress told us to, which is always a really good reason. The second of which is that we're going to see that these systems are absolutely integral to our energy systems. They're going to produce energy. They're going to be coupled with marine energy systems, such as wave energy or offshore wind. And they're going to be important demand aspects for our energy systems. We need to make sure that marine CDR is considered and integrated within those systems appropriately. And so I also want to point out that when we think about the work that Department of Energy is doing, there is a much broader suite of carbon dioxide removal opportunities and technologies that we're working on, but marine CDR is a really important and crucial aspect within that portfolio. And so thinking about long-term objectives, we set a core energy earthshot as Department of Energy, really a department-wide call to action specifically, thinking about what we need to do in the next decade to get these technologies to scale. And that piece is really this $100 per ton net CO2 removed target. And so we're not thinking that any one of these specific technologies is gonna hit that $100 ton target, but in fact that across the entire portfolio, we might be able to realize that. And so there are a couple of important qualifiers here. First, we want robust full life cycle accounting. This is a piece that Department of Energy has historically been very good at, thinking about all of the greenhouse gas emissions fluxes, both energy systems in and out of a given technology, but also thinking about greenhouse gases beyond just CO2, thinking about methane, for example, or other global warming potential gases that could also yield either upsides or downsides to these technologies. The other piece is high quality and durable storage, making sure that we actually have long-term permanent separation or isolation from the atmosphere or from our ocean so that there is a durable and long-lasting climate benefit. And so I sort of talked about this at the beginning, but we're really not working towards deployment quite yet. You can see that the arrows sort of move from basic research and development to lab scale design and prototype, and finally to field validation. And where we're at today, if you can see the little green check marks, we're mostly focusing on that basic research and development aspect, thinking also about lab design and prototyping, and eventually trying to move these technologies to field validation. And so we put out a couple of solicitations, really thinking about conceptual design and feasibility. What do these technologies look like in practice? What is their energy and mass balance? Thinking about where we might deploy them, doing some mapping, and also just provisional, I think, life cycle assessment of some of these technologies. And then we hope that next year we'll eventually be able to issue a solicitation to fund 2 different projects for field scale validation with up to $4 million per project is our ambition right now. And so to close this out, I really wanted to call attention to one particular initiative that I think is really important and a thing that DOE has historically done pretty well, which is the Sensing Export of Anthropogenic Carbon through Ocean Observation program that was recently launched by the Advanced Research ARPA-E to specifically fund technologies that give us the ability to sense where the CO2 is ultimately going. So tracking the flows of CO2 and ultimately also coupling these measurements and novel sensing technologies with models so that we actually know the long-term implications of the technologies that we're supporting within our research and development portfolio. And so I'd really describe, I think, Department of Energy's work in two key aspects. First of which is basic material design, research and development around some of the more nascent abiotic technologies for marine carbon dioxide removal. The second is really supporting the tools that let us know that that first bucket of technologies, our marine CDR pathways, actually have the impact that we hope they do, and also ensuring that there are not adverse impacts on communities or our ecosystems. And so with that, I'm going to pass it over to someone who actually does this research in practice. I have the pleasure of introducing Dr. Matt Eisman, who is currently Chief Scientist and Co-founder at Carbon.
Thanks, Rory. Hi, everyone. My name is Matt Eisman. I am an associate professor in the Department of Earth and Planetary Sciences in the Yale Center for Natural Carbon Capture at Yale University, and also co-founder and chief scientific advisor at Carbon. Carbon is a startup company based here in the Bay Area that is commercializing a specific approach to removing carbon dioxide from the air using the oceans. So EB's approach uses low carbon electricity membranes to directly move acidity from seawater, and removing acidity from seawater, it increases the alkalinity, or effectively the buffering capacity of seawater, which results in additional CO2 being pulled from the air and stored safely and durably as bicarbonate in the ocean. And so this process is actually effectively trying to speed up the natural CO2 regulation mechanism that the Earth uses for regulating CO2, trying to speed that up from hundreds of thousands of years to timescales that are more relevant for humans and human society and climate change. Just so you can picture the EB system in these membranes. Sort of think about like maybe the water softening filters under your kitchen sink, just to give you a mental picture. So EB is very proud to be part of the EASE-OA project, which stands for Electrochemical Acid Sequestration to Ease Ocean Acidification. It's always important to have fun when developing acronyms. And so this is a partnership with Pacific Northwest National Lab SWIM, a DOE lab, NOAA PMEL, and the University of Washington. And as was alluded to before, it's really a first of its kind public-private philanthropic deployment in a national lab. So within EB, we have a saying that how you remove the first 100 tons matters. At EB, we have a saying that how you remove the first 100 tons matters. And so we're really thrilled to be working with these world-class scientific partners to establish the efficacy and the safety of our process and lay a foundation, scientific foundation for this field of marine carbon dioxide removal. So in this picture, it shows EB's system on the right that's installed within Pacific Northwest National Lab. And just to give you a sense of scale, that system is about the size of a shipping container. And if it were operating at full capacity, could remove 100 tons of carbon dioxide from the air per year, just to give you a sense of scale. So as I mentioned, the goal of the project is really to lay the scientific foundations, establish the efficacy and safety of the approach. And so we're really focused on these three research thrusts that I show on the slide. So first, we're working with the Salish Sea Modeling Center to improve the spatial resolution of their ocean models. And that will allow us to better predict the amount of CO2 that would be removed by an intervention like this, and also any local ocean acidification mitigation benefits that might result. The second are ecosystem studies. So we're working with biologists at Pacific Northwest National Lab to study the effects of such an intervention, which results in slightly higher pH and alkalinity in the seawater on marine organisms like isopods and oysters. And then finally, on the right, tank experiments where we're pulling seawater into the lab using EB's system to remove acidity from that seawater, and then keeping that water in tanks to perform experiments where we can really assess the speed at which CO2 is drawn into the water and the speed and efficacy of that process. So I really appreciate the chance to share a little bit about the project. Looking forward to questions, and I think I'll pass it back to Lisa.
So I have a moment to just pause, and as I think about how this is landing with our community of journalists and reporters here, I hope you might share with me the incredible awe with which our colleagues here are representing communities that have risen to this occasion of needing to address the possibilities and technologies that could be deployed for marine carbon dioxide removal, and the nimbleness, speed, and scope of their work. And it's truly magnificent and exciting. And it's been in this acceleration of the technology that AGU paused in 2022 and reflected on the critical need to develop a plan to think about the ethics of this work. Because as you can see, it is something that is emerging rapidly. So we watched a plan to develop, now this is long, get ready, an ethical, oh, it's out there. Thank goodness. And it's got a really big QR code. Okay, ethical, so I can say it faster. I was going to say it really slow. Ethical framework for climate intervention, research, experimentation, and deployment. It's a heavy lift. And to do this, we convened a diverse advisory board of global experts, not just in climate science, but also in human rights, policy, technology, and ethics. And this framework didn't start from scratch. It was building on work such as the Oxford Principles, the Tollgate Principles. There was an Asilomar Conference that recommended principles for research into climate engineering. But it also drew upon ethical guidance developed from other rapidly advancing areas of technology. And our goal in designing this framework was to guide governments, researchers, international organizations, NGOs, and especially the private sector that may be engaged in climate intervention and research and policy, and to develop the ability to help them use policy to plan their work from an early stage. In 2023, earlier this year, we published a working draft for public comment. And these preliminary principles in that working draft are a result then of insights collected through workshops, summits, surveys, and outreach discussions with participants literally from around the world. These principles focus solely on the ethics of research experimentation and deployment of such measures, not the development of policy around the measures. Once again, it's about the ethics. We are not at this point being policy prescriptive as AGUs. They focus on climate intervention in general, but with the distinction between carbon dioxide removal and solar radiation management. There's sort of separate ethical considerations in those areas, as well as in other climate altering technologies. It is key that it is informed and built for society. This is the big tent approach. When I reflect on it, it's notable because so much of what we tend to do these days can be done in kind of an echo chamber where we're listening to each other versus listening to a larger global conversation here. And AGU stands solidly with the larger conversation. So we love debate and discussion from the public and from private sources. Our goal is to convene the experts, to create the draft, and then to foster the conversations to improve and socialize the draft, and to elevate the importance of ethical governance, but not to be the governing bodies ourselves. So with that, I thank my fellow panelists, but particularly thank you for being here. Been watching you taking notes. I hope somebody's taking pictures of that QR code. Okay, there we go. And Liza, are you going to help me with manage the Q&A?
I sure am. So thank you, panelists, for your presentations. We're going to turn it over to the floor to all of you. If you have a question on the floor, please raise your hand. I'll bring you a microphone. If you're online, please put your question in the Q&A box. Make sure you identify yourself. And when I hand you the microphone, please identify yourself and your outlet if you can for us and for the panelists. And panelists, I'll also remind you to please say your name again when you start speaking for folks in the back. Do we have a taker on the floor?
Sure. So thank you, panelists, for your presentations. Thank you for your time. 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 Thank you for your
questions?
Hello, my name is Amy Mayer, and I'm a freelance public radio journalist here in the Bay Area. Could you tell us more about some of the ethical concerns that have already come up, that have been discussed, and what some of the challenges what challenges have presented themselves so far? I don't know if that would be from Ebb Carbon or from the others, but I appreciate the advancing of an ethical framework ahead of major concerns, but I'm curious what some of the items are that prompted the need for it.
So, how do you feel about it? I'll start and say, describe a couple of them, and then do you want to talk about how this plays into your role both as a scholar sort of at Yale, but somebody that's really got their sleeves rolled up and is doing the work? So when we think about deployment, we believe, will be based, if and when it occurs, at scale, and at the scale that we increasingly feel urgency about, both for carbon emissions, but importantly, as Steve pointed out, for legacy carbon, or our history of emissions up until this point. There's a big question of who decides when and where. And so ensuring that there is research that brings the best data, experimentation, and modeling approaches together to be able to make a forecast of what the impacts are likely to be, and then to have the convening that is necessary to sort of guide in a transparent way the way in which this might be deployed. Sometimes I think about the emergence of the Human Genome Project and the degree to which, as the excitement of the results started to come in, there was a need for a community to decide how and when this would be deployed, what was okay and what was not okay. I'd say this is even more complex because of the power differentials and the complex geopolitics of fossil fuel emissions and impacts. So do you want to comment about how you interact with the notion that AGU says, let's have ethical principles? Is that good news or bad news, just to be slightly provocative?
No, I think my name is still Matt Eisman. People in the back. I think it's actually very welcome, and it's also true from the ethical framework perspective and from regulation perspective. I think all of the practitioners in this space really welcome guidelines. And the question of what ethical concerns come up in this space, one that we hear a lot is this moral hazard argument, which is, well, if we do carbon dioxide removal, maybe people will think we don't need to decarbonize and reduce emissions. So that is fairly easily met with the data that now it's clear we need, first of all, to decarbonize. So we're always very clear. First, we need to decarbonize, but to avoid warming beyond where we want to go, we, in addition, need carbon dioxide removal. And we've, in some sense, put ourselves in this situation, right? If we had decarbonized quickly enough, we would not need to do this, but we do now. And I think another, on the ethical framework side, we're doing this work in communities, right? And so there are social and environmental justice aspects that we absolutely need to consider first. So yeah, very, very welcome to have these frameworks developed.
Thanks, Steve. Thank you for that question.
Hi, my name is Mary Miller. I'm a local freelancer from the Bay Area. I have a question about who will pay for this, and I would like you to address how do we know it's working? Because there's one thing to put into place. We're going to remove 100 tons, but how do we know that's actually happening and it's effective, and what proportion of the costs are going to be data and monitoring as opposed to actually doing the reduction?
I can start and then pass it along. I'll start with the last question, which is on how we know it's working. So this is a huge aspect of the field right now. People refer to it as monitoring, reporting, and verification, or MRV. And so this is something that the practitioners themselves within these companies have teams to do that, but this is really a larger scientific community question that national labs and academic institutions, oceanographic institutions are helping develop that framework for. In the example, in our process, the way it works is essentially we're slightly adjusting the chemistry of the seawater by removing the acidity. So we can measure that pretty close to where that's happening. And then as that goes out into the ocean and diffuses, that signal becomes weaker. So we measure as far out as we can, and then we use those data in ocean models to run those models. Here's the case where we performed this intervention versus where we didn't. And then those models are intercompared and calibrated. But yeah, that's an active and super important area, the MRV aspect of what's going on now. On the who will pay for it aspect, I can at least say that right now, companies have come together to form, for example, the Frontier Fund and form basically the voluntary carbon market, right? So to meet their net zero commitments, they have pledged advanced market commitments to purchase carbon dioxide removal from some of these practitioners. So for example, Stripe has purchased carbon dioxide removal from Ebb Carbon. But I'd be interested in the other panelists' view on going forward, who will pay for it beyond the voluntary carbon market.
Yeah, I can hop in there. So Department of Energy, let's see, about 2 months ago announced a CDR purchase pilot prize. And this is fundamentally an effort to understand whether or not Department of Energy could be a demand side effort for carbon dioxide removal as a service, thinking about purchasing carbon dioxide removal credits from the voluntary market. We're expecting, actually, applications, I think, for that are due tomorrow. And we'll have, a series of phases over multiple years at which these companies will compete for awards with the federal government, maxing it up to $3 million per company. So it's relatively small dollars compared to sort of the billions of, or $1 billion is the Frontier commitment?
Yeah, the Frontier Fund is around $1 billion.
Right, so it's relatively modest in comparison, but I think the idea is to understand, could the federal government purchase carbon dioxide removal? What technologies could potentially be providing durable, well-measured CDR? And then ultimately whether or not there is a role for the federal government to do that.
Thank you. Thanks for being here. My name is Juliette Grable. I'm a freelancer from Oregon. I think my question's for Matt. I'm curious what a scaled up facility based on the technology you're working on might look like and what the impacts to a community, both positive and negative, might look like.
Yeah, that's a good question. So I showed a picture of this system that looked kind of the shipping container size and about 100 tons of CO2 per year. We're targeting already industrialized facilities that already have pipes with brine flowing out to the ocean, right? So we plug in, think of a desalination plant or a power plant that use the pump seawater for cooling. They're already doing that, and there's already essentially a waste pipe of that seawater going back to the ocean. We would plug our system onto the end of that and in some sense create value out of that waste by removing acidity from that seawater.
Hi, this is Priyanka from Chemical and Engineering News. You were talking about scale, and I was just wondering if, given the kind of setup that is needed to make this happen, are we mostly talking about national waters, so where land and stuff like this is accessible, and international waters are sort of out of boundary for stuff like this?
Yeah, so for Ebb's process, we are coastal, if that's the question, yeah.
So, and I will add here too, and we're working very closely with our colleagues at the Environmental Protection Agency at the federal level, working hand in hand with them as we work through our research portfolio and issue permits. So we do have one project right now that will be exploring an alkalinity release in the Gulf of Maine, and they're starting the permitting process for that. But I will stress that's at a research level. So we have the London Convention, London Protocol, And national waters across the globe have their domestic policies that enact that London Convention, London Protocol, which is the ocean dumping kind of regulation. The US is a party to the London Convention. And so right now, that body is stating that they will only consider research, not any kind of deployments at scale in an open ocean.
Hi, Todd Woody with Bloomberg News. Some electrochemical ocean CDR is projected to use enormous amounts of energy. Aquatic startup spun out of UCLA estimated in a 2021 paper that to deploy at gigaton scale, it required $1.4 trillion investment to build out solar power plants. What are your plans, Matt, to meet that energy demand? And is this the best use of renewable energy rather than using it to offset or reduce carbon or fossil fuel?
Yeah, it's a good question. So in our case, when we design our systems, we design the systems and the techno-economics to assume we are operating 50% of the time. So our capacity factor is 50%. Our specific electrochemical technology can be turned on and off within tens of seconds, which means we can actually provide grid flexibility by turning on and off when low carbon electricity is available and when the carbon intensity of the electricity is lowest. And so what that means is it actually enables the build out of more renewables than if we weren't providing that service.
Hi, I'm Dan Grossman. I'm a freelance journalist from Boston. And I'm not sure if I completely understand the technical aspects, the chemistry of this, but it seems to me that if you're taking out the acidity, that must mean that you are increasing the alkalinity. And so essentially, these systems would be a point source of alkalinity. And I'm wondering what the biological impacts are of creating a point source of alkalinity, which of course will then diffuse out and presumably actually be beneficial in reducing the acidity of the entire ocean eventually. But you would have a high air concentration, I presume, of alkalinity right where the system is.
Yeah, that's correct. So that is part of why we're performing these studies with biologists at Pacific Northwest National Lab that I talked about. So making sure we understand the safe limits for operating in terms of the marine organisms nearby. And it is like you described, sort of at the dispersal site, there's a mixing zone where the effect of what we're doing is largest. And so our safe bounds of operation will be governed by essentially what slightly increased pH, what's the maximum increased pH we could have in that mixing zone. And then as you go further away from that, it becomes less. There's actually an interesting benefit to what you described as well, because you can think about using our systems to locally keep the ocean chemistry conditions back to more pre-industrial conditions before ocean acidification. So you could actually locally, not globally, but locally mitigate ocean acidification in regions that could be beneficial to shellfish and shellfish farmers. But yeah, you're right. That's exactly why we're performing those studies, to understand what the safe bounds of operation are.
And I also wanted to flag a lot of our awardees, our grantees, including, the work that UpCarbon is doing, is specifically looking at the ecosystem impacts, the biological impacts of these kinds of climate mitigation strategies. I'm based in the ocean acidification program at NOAA, and this was part of our motivation to contributing and leading these efforts, is to understand the potential for ocean acidification mitigation very locally.
And if I may add to that, Steve Thur, we've profiled one potential MCDR technology. There are others, and I think Gabby provided a slide with several others that are more diffuse in nature, and so may not result in the point introduction of alkalinity like electrochemical ocean alkalinity enhancement may.
Mary Miller, freelance again. I wanted to return to this question about the voluntary carbon markets as a mechanism to pay for carbon dioxide removal. To me, it seems that the moral hazard is more in using this as a way to continue emitting fossil fuels. In other words, if a fossil fuel generator says, oh, we're going to now be able to provide net zero gasoline for your car because we are contributing to this reduction, instead of what's Dr. Thur said at the beginning was, we need to do this in addition to decarbonizing. So how are you approaching that question about it being not a moral hazard for individuals, but for fossil fuel generators using this as a way to continue business as usual?
I might jump in there and then pass it to folks who are thinking about the carbon market. So a point that I didn't quite stress enough is the difference between carbon capture and storage and carbon removal. So if you think, you probably heard a lot about carbon capture and storage. I know there was a lot of discussion at this, specifically at the conference of the party in Dubai. But that is really going towards reductions. So this would be, point source capture of carbon to reduce the new emissions coming out of something like a fossil fuel plant, a cement plant, et cetera. Carbon dioxide removal gets at exactly that. It's removing legacy carbon, as Steve mentioned in his remarks, from the atmosphere. And so we're really thinking about cleaning up legacy pollution rather than reducing the emissions of new carbon. That being said, I understand your philosophical dilemma, especially in terms of these big, we call them offtake agreements to kind of balance the carbon budget sheets of large companies. So I'll let somebody else comment on that point.
Yeah, I mean, I can provide some introductory remarks. And again, Rory Jacobson from Department of Energy.
Forgetting to introduce myself.
Yeah, it's tough. I mean, I think that the stance of our office is that if you can decarbonize it today, you absolutely should. If it's an opportunity to do electrification or to do point source carbon capture and storage, we should absolutely prioritize that. I think Dr. Thur put it perfectly, that we're thinking about the CO2 that's already in the oceans and atmospheres. We don't regulate the voluntary carbon market, and we can provide guidance on how we think that folks should think about these issues. But ultimately, it is up to the private sector how they want to do their scope 1 through 3 accounting.
Could I just add one more thing to this, which is this can sound pretty nerdy and technical, and I see it as one of the most important ways we need to engage the public about whether we call it the moral hazard, where we, sort of like at your next dinner party, you say, like, I heard the most interesting talk about legacy carbon. Nobody's going to know what the heck you're talking about. And so I really feel it's so important. I think I'm speaking now for the panel as well, certainly for AGU, our partnership with you who help us translate this into metaphors and ways of thinking and talking about it is absolutely critical. So once again, huge gratitude to you for being here and asking the kind of questions you're asking.
Amy Mayer, freelance, Bay Area. I wanted to stick with the voluntary carbon market subject just for one more moment, which is, and this question is for Rory, as DOE is thinking about what it might contribute to discussions of the carbon market or how it might participate, are you engaging with other federal agencies? And the reason I'm asking is specifically about USDA, which I know is also trying to deal with what, if any, role it should have with markets for farmers.
That's a great point. And I think that, so again, Rory Jacobson from Department of Energy, I think the distinction is that there is policy that has directed USDA to at least do some provisional assessment of the voluntary carbon market, thinking about specifically the areas where they have expertise of forest management, agriculture. There isn't the same sort of directive for Department of Energy at the moment. We definitely have engaged thoroughly with other agencies that could potentially regulate these markets, either from a commodities standpoint, thinking of the CFTC that's recently issued actually draft rules on this issue. But yeah, have absolutely brought our technical expertise, I think, to bear with regulatory agencies that might consider issuing guidance on that issue.
Hi, I'm Chelsea Harvey with E&E News. Thinking about even small scale field trials, I think there have been some fairly high profile examples that were either proposed or carried out in the last few years. And these are mostly geared towards solar radiation modification, but still I think there are some cautionary tales there of field trials that were either proposed or carried out that resulted in great public outcry from communities that might have been affected. And so I'm wondering what frameworks are in place or being put in place to ensure that local communities are involved in those conversations? And Gabriella, a minute ago, I think you mentioned a project exploring alkalinity release in the Gulf of Maine. So I'm wondering if that was something that came up there. And in general, how are you thinking about addressing those concerns? You want to touch on your communicator?
I'll pass it off to you, but I'll just briefly say, so it's not my area of expertise at EB, but EB has dedicated significant resources to folks that's their entire job is community engagement.
Yeah, and I'll also mention in our research portfolio for marine carbon dioxide removal. Oh, this is Gabby Kitch. Sorry, I'm finally remembering to introduce myself from NOAA. So in our research portfolio, of the 17 projects, 7 of those focus on community engagement. So we have one project that's dedicated to engaging the fishing community in general on these topics. And then a lot of the field-based trials as well are doing a lot of community engagement. So many of them have brought social scientists onto their team to lead that engagement. Others are working hand in hand with sea grant programs or others to grow their community engagement. I think a lot of the scientists that are working in the space are looking closely at these ethical frameworks. The Aspen Institute also just released a marine carbon dioxide removal code of conduct as well that outlines not necessarily the how to do this kind of work, but the large issues and the steps that researchers should be thinking about, even in terms of laboratory work, to really fuel the conversation of community engagement and social interactions.
If I may opine, this is Steve Thur, also from NOAA. I was asked earlier in the week, what keeps me up at night? And one of the responses I give is, as a trained scientist, I've been ingrained to think of the precautionary principle, that when we're thinking about something that could potentially have negative implications for the Earth system, we have to understand those very thoroughly before we take action. And our scientific method is developed to be very methodical. It is also sometimes ponderous. In thinking about the scale of the challenge before us and the urgency to address our changing climate, the precautionary principle brings on new context. And so I believe, getting back to your question, you see various actors in this space with different levels of comfort in accepting aspects of the precautionary principle. Should we try something, recognizing the counterfactual is doing nothing just yet, may be worse? And this is something that I think our professional community is struggling with, and is something we're going to have to engage the local communities in which we are deploying these potential technologies.
And if I can add to that, Rory Jacobson from Department of Energy, I also wanted to flag that, with all of our bipartisan infrastructure law programs, 20% of the evaluation is on community benefits plans. And there is extremely comprehensive guidance throughout the DOE websites that support folks that might apply to these programs in developing a really comprehensive outreach and engagement strategy. So not just thinking about potentially some of the risks that could impact communities negatively, but also thinking about some of the co-benefits that could be associated with these projects. And they really are very tailored specifically to thinking about a specific technology in a specific community and how to do that outreach appropriately.
Last call for questions from the floor. Then I'd really like to thank our panel for being here today. This has been recorded and will be available on AGU's YouTube channel. We'll make the slides available to you on the Press Information Exchange, as well as links to this report and the others that have been presented here today. We hope you will join us here in the afternoon for a roundtable workshop in the other adjacent room from National Geographic about water resources around the world, how you might use them in your reporting. We'll be back here in this room tomorrow at 9 a.m. for our final press conference that is about Ukraine and its agricultural impacts from the current conflict. Thank you for coming.